Good evening, everyone. My name is Lily, and I am a software engineer. And in my spare time, and sometimes even at work during my lunch breaks, I crochet. So I guess that also makes me a software engineer. Brace yourselves, there'll be lots more terrible puns along the way. When I first learned to crochet, getting hooked on making little flower after little flower, I realized, being a developer, that I was basically doing a computer's job, passing instructions at runtime. And this made me think that crochet and other yarn crafts more broadly may be a form of programming hidden in plain sight. And it seems crochet is popular. This is a graph showing the trends in Google searches for knitting and crochet. And the red one is crochet. And especially in lockdown, I think everybody wanted to make Harry Styles' cardigan, started Googling how to crochet and learning, which is a great way to learn. The first similarity we can see between developer and crocheter is the community brought to you by the power of the internet. If I want to learn about a new programming framework, I look for a blog, a forum, a screencast. If I want to learn new crochet techniques, I can do the same. I learned crochet watching YouTube videos. Before crochet terms became more common in the middle of the 20th century, the books of patterns you could find were of actual sample that you could study and reproduce. And to me, that feels surprisingly like CodePen, Stack Overflow, or Gists, which are online platforms where you can share snippets of your code to be reviewed and reused. And if we look at the history of crochet and computing in parallel, we can find some more similarities, not only in the way of programming, but also in the behavior of their respective communities. And tech is about people more than computers anyway. So a tangled history of crochet and computing. Similarities occur at the very root of computing and yarn crafts. There is often an argument or a discussion on whether software development is a science or in fact a craft. Both imply a competency, a skill from the operator, and in people's minds, tech equals science, because a lot of equations needed to be solved to get where we are today. And science instantly evokes knowledge, empirical data, whereas the word craft, which comes from the Old English creft with a K, evolved to mean something built or made. Now, I don't know about the programmers among you, but I often have to wait for my builds to finish when I code. So in software, we also thrive to refactor our code to find more elegant, more crafty solutions. And in crafting, there is the notion of transmission to an apprentice or more widely a community that we find in software too. So it looks to me like we are indeed going to be comparing two crafts. This is Mademoiselle Eleanor Riego de la Branchardière. Mademoiselle Riego for short. Contrary to what name might suggest, she actually lived in Ireland. And we don't know a lot about this lady's background and origins, but she was a very influential figure in the 19th century world of yarn crafts, particularly lace and Irish crochet. And she wrote dozens of pattern books, allegedly from a very young age. And another interesting fact about Irish crochet is that in Ireland it's said that you leave a bit of your soul trapped in everything you crochet. So to avoid this, you should always work in a hidden mistake so that your soul can escape. This is similar to other superstitions in woven textiles. For example, carpets in the Middle East have deliberate flaws so as not to offend God, because only God can be perfection. And to me, that sounds very much like the "this is a feature, not a bug" excuse that you often hear in programming. Back to Mademoiselle Riego and her pattern books. So, in my opinion, she was, and this is where it can be a bit controversial, a pioneer in open source. Open source crochet, of course. Let me explain my reasoning. As I said, she was very prolific in publishing pattern books. But at the time, the middle of the 19th century, you couldn't write down patterns because there was no common terms for the different stitches. So instead, what she published was an actual collection of samples of her own designs that people would easily reproduce and amend by looking at them. And that's kind of a reverse engineering by exploring the source code. And this evolved into the 20th century when yarn manufacturers paid designers to crochet on the end of balls of yarn so that you would buy it and carry on straight away as you go home. just like forking a project and making your own adjustment if you are GitHub users. And speaking of which, the modern GitHub version control platform with input from a community for crochet is Ravelry. There are other platforms, but that's the main one. And designers can post their patterns for other crafters to use, to make, to test, and posting feedback or recommendation on a pattern is akin to opening an issue or a pull request. Crochet and computer software have both evolved over time through innovation, natural selection, and their respective communities. Ooh. Click. And the evolution goes a bit like this. You borrow some code, modify it, test it, fix it, modify it, test it, fix it, and at some point in that cycle, preferably when it's fixed or tested, you share it. This is Jacques de Vaucanson, a Frenchman and a fairly clever cookie. His specialty was building automatons in the first half of the 18th century. He then became a director of silk mills in France, and that's really where the interweaving starts. In 1745, he toyed with the idea of a punch card system for controlling weaving patterns, trying to automate a very manual process. This helped the foundation of the jacquard loom in 1801, which in turn influenced the early history of computing, as you might know. And this brings us to Ada Lovelace, whom we're celebrating today. In the middle of the 19th century, so around 1842, that's about 100 years after Jacquard's punch card system idea, she helped Charles Babbage in his endeavor to build the analytical engine heavily inspired by Jacquard's loom and punch card system. And the terminology for the analytical engine is also borrowed from the textile industry. The yarns were brought to a store from the mill where they were woven into fabrics and then sent back to the store to be sold. And in the analytical engine, it isn't yarn, but numbers that are brought to the store from the arithmetic mill for processing, and then the results of the computation are returned to the store. And I think Ada Lovelace said, again with this metaphor of weaving, the analytical engine weaves algebraic patterns just as the jacquard loom weaves flowers and leaves. And as we know, Ada Lovelace was also one of the first computer programmers creating algorithms and patterns to be computed by this new machine when finished. Just like Mademoiselle Rigaud created crochet patterns to be computed by humans. Now, if you want to make engineering more obvious, why not combine yarn and Lego? A winning, inspiring combo, in my opinion. So let's have a quick look at this Lego weaving loom. There's quite a few on the internet. It's a good time sink if you've got nothing else to do. Very mesmerizing. Right, back to history. So the analytical engine was purely dedicated to calculus, and that was in theory because it was never finished. Whereas Ada Lovelace saw beyond simple arithmetics and envisaged more complex tasks to be performed by the machine. In a way, a crocheter always counting stitches is an organic analytical engine, with the stitches, the instruction, and the yarn being fed through the hook like data into a computer. So by now, I hope you can see more parallels emerging between crochet and computing. And if we follow the thread a little further, we could say that computer software and crochet software appeared around the same time. If we take the definition of software being the programs and information used by a computer. And we've already established that there are human computers, so there is such a thing as crochet software. Stretching this theory a little more, we could affirm that crochet software is a form of self-replicating information that gets passed from one crocheter to the next. The early recorded techniques for crochet were so simple to learn that it became automatic to perform. People would crochet anywhere whilst praying, traveling, talking, eating, as I do on my lunch breaks, or watching TV. So there is a form of automation in both mechanical and human computers. In Ireland, crochet techniques evolved and spread at a time when adults and children alike had to adapt their skills to find new streams of revenue. Revenue some of them could get through selling their crochet makes. Similarly, today we see multiplication of code clubs or women who code initiatives, spreading coding techniques and insights to one and all. In the mid-19th century, there was a reduced number of stitches compared to today. Their names didn't matter so much as no instruction was written down, as we saw earlier. And apart from the chain over there, I don't think any of those names are still used today. But we'll see an evolution in the programming language emerge a bit later. So let's get a bit technical. No matter how complex the crochet stitch, it always starts with one loop on the hook and ends with one. There is a pre-production process in crocheting where you select your yarn type, your hook size, check the tension as per the instructions. In a way, it's like making a small unit test. You end up assembling a few rows together and measuring the output to ensure it is as expected before you go too far. By 1950, the names of the basic stitches printed in the UK had been standardized. Finally, a universal programming language. Or not. At the time, and even today, a high proportion of other English-speaking countries still use different names. So if you were unaware of the differences, your end result might be far from the expected one. Fundamentally different stitches can share the same name in distinct languages. Let's say, spot the difference. A stitch called a UK double crochet is a US single crochet. So that means they correspond to the same yarn hook combination. But a US double crochet is then a UK treble crochet, and so on. You get the gist. And that's just for English-speaking countries, but other languages have their own terms as well. So American English, differently to computer programming, doesn't rule the world of crochet programming just yet. Luckily, there is also a visual language, a master language, if you will. That's your binary zeros and ones. That can be translated into any local version. No matter what language you speak, each symbol on those charts will always mean the same thing to you. So, moving on, this is what part of a written crochet pattern would look like. This one is for Yarnspiration, which is a different resource than Ravelry mentioned earlier. And we can already see in a pattern that got scalability for various sizes, variables in the color changes, and loops and recursion for repeats. Stitches can be combined into a near infinite number of designs, just like the primitive elements of a programming language can be combined into any program. If these crochet instructions were written in JavaScript, for example, if you're a web developer, this is what they could look like. Both in crochet and programming, it doesn't matter what language you know, as long as you understand the underlying logic. Live demo. So, so I can see my screen. Here I am, a human computer with a compiler in my hand, the hook, interpreting a pattern at runtime. Although I have prepared for today, it is fair to say that I am following a pattern and it hasn't been loaded into memory just yet. This is right. And as I come to color change here, color changes, I will have to deal with literal multi-threading. I need to manage 2 different strands of yarn at the same time when I change over. And while crocheting, I can sometimes encounter race conditions. For example, if I run out of yarn before I finished, or if my mind races ahead and the hook doesn't quite follow. Crochet and programming can even share the same language at times. Take blocking, for example. Thread blocking in software means that your thread is suspended and more often than not, your application will crash or hang. In yarn crafts, it means fixing the panels of a garment to the correct shape and size, effectively preventing it from getting misshapen. Now, if I make a mistake, let's say I've made a mistake, what tools do I have for debugging? Well, the problem with crochet is that you can't see the result until it's been fully compiled. Sometimes it looks very odd until it's done, but it still works. But you can put breakpoints and step through your code. So, meaning you can wait until the next row to make sure that things are aligned. This is supposed to be on top of here. And because it's just a big interwoven loop, crochet items are easy to unravel without creating a waste of thread, just waste of time. Once you've finished compiling, of course, there's a mandatory post-production stage, weaving the ends in. The design is still in beta, it's not yet launched to the world, and won't be deemed ready if the ends haven't been dealt with. It's a bit if you leave some lorem ipsum in your content on the website. You can also choose to document your code with a README or wiki. Generally, that equates to the pattern. Or add comments if you've improved on an existing design, because how often do you really code from scratch? Now that we have the basic mechanics of crochet down, let's make things interesting and look at how we can mix this analog medium with digital. There are many ways people have been hacking crochet through the years, diverting it from its primary purpose. Yarn crafters have been experimenting with cryptography, hiding secret codes and messages in their items from very early on, sometimes to denote belonging to a community or a particular social rank. Phyllis Latour Doyle was a British secret agent who used her knitting needles to hide coded messages she sent from Normandy during World War II, and she turned 101 last year. More recently, Eden Cottage Yarns paid tributes to the human computers of Bletchley Park with a collection of knitting and crochet designs, such as this cardigan with a Morse code on the back, coded message. We could push the relationship between crochet and technology further and devise a computer vision program that would use a crocheted or a knitted piece as a set of instructions, and then make a punch card out of yarn, looping all the way back to the origins of computing. Another way to spruce up crochet is to ditch regular yarn and add a little bit of electroluminescent wire, like in here. There are many other ways to bring together yarn and technology or engineering. Sometimes you can give control back to the machines with a 3D printer, or even with a knitting machine or chair. A few years ago, Google and their Project Jacquard, the name should be familiar by now, have transformed woven fabric into a touch interface. It's not much fun if you leave the computers do all the work, is it? Yarn and crafting in general, after all, is a hobby. So in a more DIY fashion, we could see the same kind of interface, but with conductive thread being knitted or crocheted into garments. And for even more fun, there's one I found recently, a game made for knitting machines, leaving the output to players. So Hazuki, the description reads, the speed of the knitting is controlled by player 1, working on the knitting machine, which is here, and determines the speed at which the game prompts appear on the screen for player 2 to respond with arcade-style buttons. If you prefer more structured patterns though, because random knitting might not be your style, technology can also enhance your approach to crochet. There is a technique in crochet called C2C, corner to corner, where based on a grid design, you combine stitches into little pixels to reproduce the pattern. The difference with using regular grids is that instead of working in rows and columns, you work in diagonals in alternate directions, so you'll follow the pattern this way. When I made my first pixel blanket, the most tedious part was to stop and count the tiny squares on the sheet of paper and cross out the ones that were done. It slowed me down a lot, and I opened my favorite code editor, built myself a framework to create patterns. It's ugly, but it works. As well as making patterns and estimating the amount of yarn needed, this app reads them out to me using the voice technology available in the browser, diagonally, alternately, and per group of color. Now that was a drastic performance optimization for me. And having a voice reading out patterns could unlock access to crochet for a wider range of people. Just like software, crochet is also concerned with accessibility issues. This person, for example, had to learn a very different way of crocheting after suffering a stroke. So let's listen to how they do it.
So you have a contraption that's been made for you?
Yes. It was actually made for me by Mississauga Hospital. And when I had the stroke and went to a rehab, and that's when they did it. And actually they did it with knitting needles in it. And at the time, I could do plastic canvas that way. But I went home and I thought, okay, how can I do this with crochet? So I did. I finagled two elastic bands to put it in so it holds it steady. And I've done everything with it.
Wow, good for you. That's neat.
Yep.
Where there's a will, there's a way, right?
Exactly, exactly.
So a lot of stroke sufferers learn one-handed crochet, and that's a solution that's probably inspired by the way of crocheting in the early 19th century. In the 1820s, one would hold both yarn and hook in the right hand and pass the yarn over the hook with the forefinger. And in the 1840s, that changed to the technique we know today with yarn and hook in separate hands. Accessibility in yarn crafts has been a concern for a long time. Remember Mademoiselle Rigaud? Well, she received a Certificate of Merit in 1871 for teaching to crochet to a blind lady who then went on to make artifacts for the Pope. Last loop. As we've seen, yarn crafts may encounter the same issues faced by software developers and try to tackle them through innovation. I've explored with you the similarities and parallels of crochet and programming, and I hope you'll agree that crochet is a programming language, which means that if you're a programmer, you can become a yarn crafter, and vice versa. And to conclude, I'll say this. I believe there's a misconception nowadays that teaching kids to code will make them all software engineers. It won't, but it will give them the basis for logical thinking and problem solving that can be applied almost everywhere. And so if you don't have access to enough computers, or are worried about screen time, or want to appeal to girls because computers are for boys, then teach them to crochet. Thank you. Any pictures or additional resources can be found at this link, and if there's time, which I think there is, I'm happy to take questions.
Is it possible to define how many potential moves you can make during one point in your design?
I'm sure I had the app I built earlier that reads me the patterns. I was thinking at some point of hacking a smartwatch and try and see if the motion would count those instead of me having to count out loud, but it might be possible.